The second decision structure we use is called the switch case. The switch case is a bit different in its coding because it now introduces the switch keyword, the case keyword, and the break keyword, and it also uses the colon. The switch works different than an if statement because now you can no longer check if a value is less than or equal to, or less than or equal to. It has to be equal to only. So the variable inside the parentheses is your test variable. Once you've determined which variable you are switching on, you can then insert your cases based on the possible values of that variable. When it finds a matching case, it will execute the body of code underneath until it finds a break. There is a catch-all, just like the if-else statement. It's called a default. The default will execute if none of the cases above match. You can have as many cases as you need, and if you need to do any type of range checking, you would have to include the cases for each value in the range. Then, ignoring the break statements under each case, except for the very last one. So let's take a look. In my simple dice program, instead of saying you rolled a and then the number, I want to say the word. So I can use a switch case to switch on my variable dice. My variable dice is only going to have the values 1, 2, 3, 4, 5, or 6. So I can have a case for each one of these values. So case 1 is exactly like saying if dice equal 1. Remember, our double equals is our equality checker. So I could have written an if statement, or I could use the switch case. Since I only have 6 values, a switch case works pretty nice. So if my dice is rolled a 1, I'm going to print 1. But you notice I don't have any break statements under case 1, 2, 3, 4, 5. Only until case 6 is where I've remembered to insert my break statement. So let's see what happens if I get a value of a 1 in my dice. So it says, you rolled a 1, and then it printed 1, 2, 3, 4, 5, and 6. That's because once it finds a matching case, it will continue to execute, skipping case statements until it finds a break statement. So once it finds a match, no longer is it looking to match its data. It's only looking to break out of the switch. So I only want to print the number that is appropriate to the roll that I just had. So I need break statements under each case. So now if I set my dice to 1, it has successfully said you rolled a 1 and then the word 1. And we can continue to check all of our data, even the invalid roll. So if my dice is a 7, I don't have a case for a 7. So it should fall under the default and print invalid. Let's try. So it says you rolled a 7, invalid. Looks pretty good. Let's give it a chance on the random number generator. So this time I rolled a 1. Then I rolled a 2. Then I rolled a 2. Now I've rolled a 6. So it has successfully matched the cases as I've needed them for my dice. You can only have one variable in the switch statement, and it can only match cases exactly. So you cannot have switch dice less than 10. No longer is this a true or false condition. This is the variable. These are the matching values. Just something to note as we move forward.